Imagine a world, not too far from our own, a world painted in shades of rust and ochre. This is Mars, our planetary neighbor. It beckons to us from across the vastness of space. For centuries, humans have gazed at its reddish glow. We have wondered about its secrets. Is it a barren wasteland, or does it hide wonders yet unseen? One of Mars's most puzzling features is its dark streaks. Scientists call them recurring slope linii, or RSLs. Picture long, dark fingers reaching down steep slopes. They appear in certain areas of the planet. These streaks are not permanent fixtures. They come and go with the Martian seasons. This changing nature made them incredibly fascinating. What force could be painting these temporary marks? The universe, it seems, loves a good mystery. Scientists around the world were captivated. Everyone wanted to understand these Martian markings. When scientists saw those streaks, one idea shone brightly. Could it be liquid water? Yes, water. The very stuff that makes life on Earth possible. If Mars had flowing water on its surface today, well, that would be a game changer. Imagine, rivers or streams, however small, on Mars. This thought sent shivers of excitement through us all. Water is the cosmic ingredient for life as we know it. Finding it flowing on Mars would be monumental. It was a hope almost too dazzling to consider. The streaks behaved in ways that suggested water. They appeared to flow downhill like little streams. They darkened the Martian soil as they moved. Perhaps it was not pure water, but salty water. We call this brine. Salty water can stay liquid at colder temperatures. Mars is very cold, much colder than Earth. So briny flows seemed like a plausible explanation. This hypothesis was the leading contender for years. It painted a picture of a more vibrant, active Mars. The scientific community was buzzing with this idea. The evidence for water seemed to be mounting. But science is a journey of discovery, full of twists. Then came May 2025. A new study emerged. Published on May 19th, it offered a different answer. The scientific world listened closely. This new research challenged the water hypothesis. It suggested something far less wet. The dark streaks, it turns out, are likely not water. This news was a bit like a plot twist in a cosmic movie. So if not water, then what? The answer was simpler and drier than we thought. The new culprits behind Mars's dark streaks? Dry grains of sand and dust. Yes, just dry stuff. Imagine tiny avalanches of fine particles sliding down the steep Martian slopes. These granular flows are what create the dark markings. Not gushing brines, but cascading sand. It's a bit like watching sand dunes shift and move. But on a much steeper, more dramatic scale. This explanation fits the evidence in a new way. Sometimes the simplest answer is the right one. Researchers Adomas Valentinus and Valentin Tertius-Bickel led the way. They used a powerful tool, machine learning. They fed it over 86,000 MRO satellite images. The computer helped catalog over 500,000 streaks. Section 4, Life on Mars? Recalibrating our cosmic search. So what does this mean for finding life on Mars? If the streaks aren't flowing water, it changes things. It makes the surface of modern Mars seem more challenging. More challenging for any tiny microbes trying to survive. Those specific RSL locations are likely not watery havens. This news might feel a little disappointing. We all hoped for easily accessible liquid water. The thought of tiny Martians swimming in briny pools was exciting. But science is about facing reality, whatever it may be. The universe doesn't always give us what we expect. Does this mean Mars is lifeless? Absolutely not. This discovery doesn't rule out life on Mars. It just guides our search in different directions. The quest for Martians, big or small, continues. We just need to adjust our cosmic treasure map. Perhaps life isn't thriving on the sunny slopes, but Mars is a big planet with many other places to look. The search for life is a marathon, not a sprint, and every new discovery helps us run a smarter race. We are still very much in the game. Mars has vast quantities of water ice, especially at its poles and buried underground. Could there be liquid water deep beneath the surface? Section 5. Mapping the future, guiding our Martian footsteps. One truly stellar outcome of this new research is a map. Not just any map, but the first global map of these slope streaks. Imagine charting every known dark streak across Mars, thousands upon thousands of them. This was a monumental effort by the research team, using all that MRO data and machine learning magic. This map is a new window into Martian surface processes. It shows us where these dry flows are most common, and it helps us understand the conditions that create them. A detailed map is a treasure for any explorer. Why is such a map so incredibly important? Think about our future journeys to Mars. We plan to send more advanced robots, and one day, brave human astronauts will follow. Where should they land? Where should they explore? This map helps answer those crucial questions. We need to choose landing sites that are safe, and scientifically interesting, of course. Knowing where these active sand flows occur is vital. It's like having a weather map for Martian landslides. Safety is paramount for any space mission, especially when humans are involved. These dry granular flows are essentially landslides. Section 6. Not a dead rock Mars dynamic dance of dust. Even if these streaks are not water, they are still amazing. They tell us something very important about Mars. Mars is not a dead, static rock in space. It is a geologically active planet. Things are happening on its surface right now. These dry avalanches of sand and dust are proof. The Martian landscape is constantly being reshaped by wind, by dust, and by these granular flows. This dynamism makes Mars an even more fascinating world. It's a planet with its own unique geological pulse. Let's think about how these dry flows work. Mars has much lower gravity than Earth, only about 38% of Earth's pull. This means particles can move more easily. The Martian atmosphere is also very thin, about 100 times thinner than Earth's. These conditions affect how sand and dust behave. They can flow down slopes in ways we don't often see here. It's a different kind of physics at play, a uniquely Martian dance of dust and gravity. The new research also found something interesting. These streaks are more common in certain areas with strong winds, for example. Section 7. The universe whispers. Every discovery a stepping stone. Some might ask, was the water hypothesis a mistake? Was it a waste of time and effort? Not at all. This is how science works. Science is a process of exploration and discovery. We form hypotheses, ideas about how things might be. Then we test those ideas with evidence. Sometimes the evidence supports our ideas. Other times it shows us a different path. Proving an idea wrong is just as valuable as proving it right. It means we've learned something new and important. This discovery about the RSLs is truly crucial. It doesn't close the book on Mars. Instead, it helps us write the next chapter more accurately. It refines our understanding of the red planet's environment. It tells us that surface liquid water is rarer than we hoped, at least in these specific sun-warmed slope locations. This knowledge makes our search for life more focused. We can now concentrate our efforts on more promising areas like searching for subsurface water or signs of ancient life. Science is about constantly improving our aim. The allure of Mars, its magnetic pull on our curiosity remains. It is a complex world full of surprises. Each new finding like this one from May 2025 is a gift.